Well, thanks everybody, and welcome to the MetaMask Web3 Wallets, the Next Evolution talk here at Devcon. We've been working for a good portion of the of this year on a variety of improvements that address a lot of the critical problems we've been consistently hitting throughout our development. We've been making a wallet now for almost 4 years. And we think that we have finally hit upon a couple patterns that can really help the whole ecosystem take one of the next large leaps that it needs to take towards three aspects: security, utility, and usability. And those are going to be the kind of themes that I frame this talk in. And a little bit later, we're going to get into some code examples. And then hopefully by the end of this, you're going to be ready to start developing a totally new kind of dApp in a way that you did not think was possible at the beginning of this talk. So I'm really excited to share our work with you. So let's just start with the current state of things. So modern wallets, as we know them today, are very limited, right? We've got this kind of trifecta that, you might think it's a choose two of three between security, usability, and utility. But how are they limited? Let's go down one at a time. So in terms of utility, wallets just don't innovate fast enough, right? So they don't add the networks that you want to their menu as fast as you'd like. They don't integrate all the new EIP features. We're always behind a few token standards, and there's always new asset types, and there's always new kinds of interesting features that people are proposing for wallets. And I would posit that a single team really has a hard time keeping up with these. It may be impossible. Wallets don't support all the latest scaling strategies. They may pick one or two to focus on, but right now there's no general purpose wallet that can just handle these. They don't support the latest contract accounts. Today, every time there's a new contract account, they basically have to build a whole wallet from scratch, and they have to promote it like, maybe this is the contract account that will not have bugs and will take you to the next 20 years or whatever. But can we do something more general purpose? They don't support preferred hosting services. Maybe you don't like being stuck on Infura. Maybe you want to provide your own new decentralized hosting service. Hardware wallets are another booming economy full of innovation, and it's, again, hard to keep up with. And also there's lots of innovation at the cryptography layer. We've got ZK snarks and starks and bulletproofs and all sorts of things that could massively benefit people if people just had a useful way of using them. Furthermore, wallets just aren't secure enough. They're built on a pile of unaudited dependencies, and that pile just gets bigger. And with all those features that everyone wants merged, each feature merged actually increases the attack surfaces. You've got new dependencies, you've got new contributors, you've got new code that people aren't necessarily reading carefully. And wallets today, they're either going to rely on a user memorizing secrets, some centralized service to assist in backing up the user's accounts, or some new and potentially vulnerable contracts. And while I'm a huge fan of things like formal verification, I think there has to be an amount of user choice and personal, deliberate desire for the risk that comes with using a new kind of account. And lastly, as everybody knows, crypto just isn't usable enough. Installing an extension is obviously a big pain. Can we make this a more progressive experience? I think we can. Browsers themselves are a little archaic and can be a little clunky in the phone. Is there a way that we can allow wallets to more seamlessly integrate with the environments that users want to interact, be they native apps or points of sale or something else? And of course, seed phrases are passé, and there's a whole ecosystem booming full of alternative backup schemes. But again, you end up having a whole wallet built around each alternative backup scheme, if only there were another way. And then, of course, acquiring the first crypto has always been a pain, and meta transactions present an alternative to that. But again, today, wallets are kind of baking in a meta transaction scheme, maybe their own relay network, and now you have to try to convince all the dApp developers to use your particular meta transaction scheme. And so you end up getting a lot of vendor lock-in like that. And of course, confirmation screens are a big pain. How can we get fewer of them? And then even when we show them, they're largely unreadable to users. So So we're left with this huge problem. How do we keep expanding innovation while staying secure and actually making the entire experience more coherent and useful and usable to ordinary people? How do we balance these? Well, I've got a little proposal. What if we say it's basically all just delegation? When you do delegation right, you've got a human readable permission that's machine enforceable, and itself can be delegated, which means that you reduce user confirmations. If a user can batch confirm a set of permissions, eventually they're trusting kind of discrete clusters of processes that can then expand their own utility gracefully. So we've started this path. Earlier this year, we've started EIP 2255. It's merged as a draft. And it's a framework for wallets to expose a permissions framework. Basically, a wallet gets to define any number of permissions, and a user can then individually trust them. They can uncheck permissions. The spec even has room for users to attenuate or like add special caveats. So I could say, well, I'll trust you for the next 30 minutes, or I'll trust you up to this spending limit. And so we've got a framework now for users to very carefully extend permissions to websites. So when you first sign in, you could basically have something like a terms of use that you sign into once, and then you could have very few confirmations throughout the rest of the app. And there's a whole design space about when should dApp developers be asking for additional permissions. I would say largely just as you need them, so that you're asking for the fewest things, you're making the least scary experience up front, but then you can just expand as needed. It looks kind of like this. This is how today, well, actually, this isn't rolled out today. We expect this to be out by the end of the year, let's say, by the end of 2019 this is. So you send a regular provider request. This method is called request permissions, and it takes an object of methods that are otherwise restricted. So if under this framework, a call to ETH accounts otherwise would throw an auth error, we're actually probably going to make an exception for that method for backwards compatibility reasons, but any restricted method would throw an auth error, and then it receives an options object that the app can use to specify the requirements. So in this case, the application requires a certain signature method to be available, but also there's a caveats parameter that allows the application to specify the conditions under which they want that permission, making the permission request even less scary. So this is a really great framework, and we're really excited to start rolling it out this year. So what wallet permissions unlock the most potential? We actually have another talk that's focusing more exactly on this. This is a huge topic, but just to give you a little taste. Some of the things we're thinking about are just the revealing of your account in general. Today, you kind of log into your account, and then every website that you're logged into sees whatever account you have selected. That's not really good. Here we have a framework. You explicitly select an account. Your permissions are bound to that account. Selecting a network. Today, most apps will actually have to tell MetaMask users like, oh, go change your network to start using, we use this network, we use, POA or XDAI or whatever. Here we can actually bake in the network request into the initial confirmation screen. And so it gives us a framework for taking that whole UX barrier out of the onboarding. You can also have spending limits. The most common kind of repeated transaction that we're seeing is spending limits granted to exchanges. So if when you first signed in, if you granted a spending limit, it's possible you could limit the number of additional confirmations involved. Also, signing permissions. There are a lot of different kinds of signature schemes. If you wanted to build a state channel framework, one way for that is to sign. A lot of people are using signatures to authenticate a Web 2.0 style backend. That can be baked into that initial prompt too. Decryption is a big opportunity. We are very close to merging a decryption method, which will allow any website to support end-to-end encryption. So you can have an encrypted chat built into your website that's all secured with the keys stored inside of MetaMask. And token management. So today, MetaMask maintains a token list. We did expose a method for websites to suggest adding tokens to your list. But here we can actually delegate even more than that. We could say, I trust Etherscan to identify more tokens in my list, or you know, I could trust OpenSea to detect my collectibles or something like that. And by that, it no longer requires MetaMask to be merging these requests. You can actually just kind of consent to the sites that you trust to help you manage your crypto experience. But what else is there? What are the most useful things that we can come up with? And I'd suggest that there's one last one, and this is going to be kind of the topic of the talk. The one permission that kind of brings it all to the next level, it would be the permission to add permissions. So kind of MetaMask, what it does at the end of the day is it adds a bunch of permissions to websites, where it adds the user's ability to consent to new permissions, specifically crypto-enabled permissions. So what we want is we want to stop telling people what EIPs can be part of the ecosystem. We want to stop telling people what contract accounts and what networks and what every little innovation can get into the platform, because there's so much creativity in this space. We just want to enable it. And so that's why we've built the MetaMask plugin system. I'm so excited to share it. So the MetaMask plugin system is a way to extend MetaMask from the dApp. It's a way of adding a script to the user's wallet that is able to enhance their crypto experience in a variety of ways. So we've taken an iterative approach. First of all, oh, this slide isn't quite working. Oh, there we go. So it uses that same permission system that I talked about before. So when you're installing a plugin, the plugin gets the same kinds of restricted permissions that you would expect from a dApp. We're sandboxing these JavaScript snippets using Secure ECMAScript, or SES, from Agoric. This is an environment where we are able to run a script that has no ambient authority. So we can run a script, it's provided, you know, maybe it's loaded over IPFS, it can define some new wallet functionality, and the user can delegate permissions to it, and it only gets those permissions. So even if you haven't audited the code, you can know very concretely that this script can't call to the network, it can only manage your tokens, and it can only read from the smart contract, for example. So our goal in sharing this now, we've got a prototype, we've got a basic framework for suggesting how this can work, and this workshop is our invitation to you to help us figure out the very most impactful uses for it, so that we can make the most safe, secure, and extensible environment that we can. But we've got some cool ideas of what it can do in the meantime to get your imaginations flowing. Oh, there goes the animation. All right. So, oh yeah. So this this would be where we show. I'll act like we see it, and I'll edit it in later. Here you can see the installation of a plugin as part of a one-click onboarding flow. So you can imagine a world where a person who doesn't have crypto today goes to a new application or a new storefront that uses the MetaMask platform and has some certain prerequisites the user needs to get started. Maybe they need some certain tokens, maybe they need a certain state channel plugin, and of course they're gonna need to be taken through the onboarding flow where they select their backup strategy and all that. And we believe that with this framework, we can basically create a single link or a single QR code that fully onboards a user, taking them from being in the context of your app through the most minimum onboarding they can, including some basic permissions requests that now equip them with a crypto wallet environment that's capable of the kind of application that you're trying to provide. And we believe that we can eventually bundle this into, yes, an extensionless environment so that you can gradually escalate somebody's security. But we think that it all works into a framework where you've got coherent user consent, you've got great security, and you've got this extensibility that just doesn't exist in the crypto ecosystem today. So some of the use cases that we're thinking about the new asset standards. We've included in our beta, we've got a sample API for managing an asset. You can just add whatever you want to the asset list. So every plugin gets assets that it can. And this is hypothetical. You know, all of these are going to go through an EIP and discussion process. But what if a plugin can just add a token? Suddenly, state channel balances can just be rendered in the wallet alongside anything else. Suddenly, new token standards. A new token standard could simply be a single plugin that lists additional tokens in the wallet. The current prototype, when you click the asset, the plugin gets to define a script that is then opened in a new tab. It could be within an iframe eventually. We're looking at new protocol support. We've got a sample plugin that will show you making IPFS work in about 20 lines of code. So we've got the ability to inject the IPFS into every website and make dApps load in a decentralized spirit today. But we're excited about more than IPFS. We want to see SSB, DAT, GunDB, and whatever other peer-to-peer database formats are out there. We want to see them flourish alongside all of these other decentralized technologies we're excited about. We no longer have to ask each wallet to integrate your layer 2 scaling solutions. It's here. We've got here at the workshop some representatives from a few different teams, including Starkware Industries, who has a working plugin where they're signing with their alternative elliptic curve parameters and are successfully signing transactions using MetaMask for their scalable exchange. We're really excited for Counterfactual State Channels, who's been one of our oldest partners in this effort. They've been working with it before it was a framework. They've just got a fork of MetaMask, kind of paving the way, showing us what they need to make this possible. We're really excited about new account types. I think some of the coolest wallets that are coming out in the last year, they're all about those new account types. We've been such huge fans of Gnosis Safe for so long, and it's an extensible wallet itself. So what is it going to mean to have an extensible wallet where you've got a contract account that's extensible? Well, I think it means that we're going to have plugins on plugins. I think that I'm really looking forward to contract accounts that themselves expose APIs for defining extensions. And this is about to be possible. Now, the account types APIs are one of the ones that we don't have as mature. So for right now, we're probably going to be hacking around it, maybe defining it as a custom asset. But again, this is where we want to take it, and we're really excited for going in that direction. And so lastly, it's just a call to action, an invitation to tell us, what would you like to see in your wallet? So some of our early beta testers are here. We've actually got several more than this. This slide is very much in draft. We're recording this video about a week before our Devcon presentation. But I want to give a huge thanks to all of our beta testers. They've been instrumental in helping guide us and sculpt the kind of ecosystem that we want to help flourish. We're constantly inspired by all the creativity in this space, and we're just trying to unleash it. So without further ado, I'd like to invite my friend and colleague, Eric Marks, up to the video where he's going to step you through some of the APIs we're exposing and how to build a basic plugin with the MetaMask plugin system.
Thanks, Dan. So to get started with this, I'm going to go ahead and share my screen. And there, I believe my screen is visible. So we have the MetaMask plugin beta repository, which is a fork of the regular extension. It has a wiki where we have a getting started page that contains everything you need to know in order to install and start load the unpacked extension into Chrome and start working with it. And that's all specified here. Now, so what is a plugin? A plugin, as far as the MetaMask extension is concerned, is essentially a manifest file in form of a package.json with a couple of extra properties and a bundle containing the plugin source code. So let's just quickly go through how you create a plugin. And so we're going to go ahead and create a folder, Hello World, here for our Hello World plugin. And we've created this command line utility mmplugin. And we're going to call mmplugin init, and it will walk us through the creation of a plugin project. And first, it'll just walk through the regular npm init workflow, which should be recognizable to many of you. And we're just going to use the defaults for the most part. Ethereum, Devcon, plugins, license. Okay, great. And we're going to be totally happy with that and continue. So we could just go ahead and use the defaults, but just so that you can see what they are, we need a local server port where we'll host it for local development, an output directory where the bundle file will live, and then initial permissions to request of the extensions, if any. And we're just going to leave that empty for now. When we're done with that dialog, we'll go ahead and create a bunch of files, build the plugin, and ensure that it runs in SES. So we'll see that it created an index.html, the dist folder, and the bundle inside of it, package.json, and so on. And now we're going to go ahead and watch these files. Oops. And serve them locally. Great, so let's go and see. So we have a plugin now. Let's go see what it looks like if we refresh. Okay, and I have the plugin version of the MetaMask extension loaded in the browser. The first thing we need to do is connect to the plugin. And so here, the DApp, like this website effectively becomes a DApp. It will request, the DApp will request to connect to the plugin and install it if it's not yet installed in the extension. So we're going to go ahead and just click submit to accept that. If there had been any initial permissions that the DApp needed, it would have requested those as well at this point. And now we're going to go ahead and send a ping, and we get back a POM. So what we've effectively, okay, what's the big deal? The big deal is what we've effectively done here is extended the MetaMask provider with a completely new RPC method that runs trustlessly inside a SES container in the MetaMask background. So let's take a look at what's actually going on behind the scenes here. Let's start with looking at index.html. What's going on here? So it has a couple of buttons. And the first thing I want to bring your attention to is the connect button handler here. So we have the in-page provider, Ethereum. Send it request. This is wallet request permissions as specified in EIP 2255. We construct an origin string identifying the plugin. So it's the location where the plugin is hosted with a prefix. And that identifies the permission to install and use that plugin in MetaMask. Once we're connected, we have this method ping. That's the new RPC method that we've added to the MetaMask provider by installing this plugin. We say Ethereum send first the plugin origin to identify, to essentially address the plugin so that MetaMask knows to route the RPC request to the plugin. And the method just has a method name and no further parameters. Okay, so, and what else? If we look at the plugin code itself, these 10 lines do everything for us. So we have the global wallet object here, this is the API that MetaMask exposes to the plugin itself. We'll talk more about that in just a moment. Register RPC message handler takes a single function which all requests from the which receives all of the requests from the DApp that are addressed to the plugin. And here we get an origin string, which is the origin of the DApp, so straight from the browser API, and the request object. We switch on the method identified in the request object. If it's ping, we return pong and get that alert that we saw inside the DApp itself. And now if I, for instance, switch this up, we see that it rebuilt. And if I go back, now I changed the DApp, so we're going to have to reload the source. So I'm just going to go ahead and delete it, reconnect, and hello world. All right, so that's like the most sort of minimal plugin that you can do. And you'll notice that what we're doing here is, as I said, extending the MetaMask in-page API. The only way we allow to do this right now is through an RPC interface. We have plans for allowing plugins to inject a more ergonomic API into the page, TBD on that, but for now, just RPC. And then here is the that wallet global inside the here inside the plugin source code itself. That it essentially provides a superset of the Ethereum provider API to the plugin itself. And all of the methods that it can provide correspond to permissions that the plugin has to request from the extension in order to use. So we have a number of different methods that you can browse here. Register RPC message handler is the most critical one. Get app key is another interesting one that I'll get to in a moment. And yeah, I highly recommend going in and familiarizing yourself with the API we discuss on this page. And now, so in plugin, like that was the most, what I just showed you was the most minimal plugin you could do. It doesn't really do anything interesting. In plugin itself, we have an examples folder where we have some more interesting stuff going on. So for instance, we can check out custom token here. And if we look at its package.json, we have, so this was of course created, was in the example we had previously. Let's show this first. You see that this is the package.json that we generated when we ran init. And the big difference here is the Web3 wallet property that contains, that identifies the bundle, where the bundle lives locally, and where it is, and at what URL it will be hosted, which we use to, which is what is ultimately used to identify the plugin and construct its origin string inside the extension. We also list the initial permissions, if we have any, which in the ping pong example, we don't. In the custom token example, on the other hand, we have this wallet manage assets permission. So as I said, that corresponds to a method, and this plugin uses that method in order to, well, first of all, it has a custom token that it defines. It just lives in memory while the plugin is running. But you can imagine that this is some unknown ERC interface corresponding to some token that lives on chain. And in the RPC message handler here, we switch on the request objects method. We can get the user's balance of this asset. We can mint in order to update the user's balance, and we can burn to decrease it. Now, the interesting thing here is that this custom asset that we define will actually be displayed inside MetaMask in the UI. So this is something that we can do today. Now, another example is the BLS signer. And here, what does it do? It doesn't require any. It doesn't really require any interesting permissions. However, what it does do is go for it.
I think you may have scrolled past it.
Yeah, I mean, it did request confirm. We're just going to cut out. We should just cut out going to that package.json because there isn't really. There's actually a typo in it. There's an old when required permissions was an array.
Yeah, fair enough.
And it's just confirmed, so it's just like.
But I think the ability to show a prompt is worth touching on, even because it also gives us an opportunity to say we will eventually make this a custom view. I think a lot of apps, 3box was one earlier today, was saying, could we render our own custom confirmation? So if you want, we can rewind a sec. We'll cut out this segment and just don't scroll down to the array. Be like, that's deprecated, ignore that. But here's a permission task that corresponds to something we do want to do. I think that's worth touching
on. Yeah, okay. So I think I was here.
Yeah, just rewind and act like I didn't interrupt.
Yeah,
sorry.
No, that's fine. So and so so in the BLS signer, we can take a look at what it has to say in its package.json. We have the Web3 wallet, the bundle, and so on. Can ignore this array at the bottom, that's deprecated. And it requests a confirm permission. And so basically what that allows this plugin to do is to render its own confirmation message in the DApp context for the user. Currently just the sort of in-browser confirmation window, but we intend to expand that to allow custom confirmations to be rendered. And now inside this plugin code, so again, we require this errors library just to render to produce some standardized errors. And we use this BLS library from NPM. And this plugin essentially introduces BLS cryptography to MetaMask. And if we look at its message handler, we have a public key that we can get, and we can also sign messages. And now, the interesting thing here is this get app key method that's exposed by the internal MetaMask API. And app keys is something that we've been researching at MetaMask for some time. And essentially, it's a key pair that's derived from the user's private key and the Dapper plugin's origin string. So we grant, with this, we grant dApps and plugins their own key pairs for the users that we can give them much more freedom with than with any of the users account keys, say. And similarly to this, our friends at Starkware, as Dan mentioned, introduce their own elliptic curve cryptography using app keys and the wallet API injected into the plugin context. And that basically does it. There are more examples inside Emmet plugin that you can check out. We hope to make more public in the next days and weeks. And you can find links to all of these repositories and wikis and so on in the video description. With that, that's my presentation. Dan, do you have something to add?
Oh, call to action. Yeah, come on down to that wiki and those issues, and that's a great place to chime in. You know, request features. You know, and in that wiki, it doesn't just show you how to use these APIs. It also there's a guide on how to customize MetaMask. So if there's APIs that we don't expose yet, you know, that's the kind of conversation we really want to have out of this, because this framework gives us as wallet developers a way to elevate the conversation from merge my feature to merge this feature that enables a new class of feature. So these are conversations that are much more efficient for us to have. So please, if you have an API we can expose that makes many new use cases possible, we want to hear them. Come on down and talk to us about them. And links in the description.